In this video, we want to find the area of the region bounded by the graph of this function here, y equal x over x squared plus 1, the line y equals 0, which is the x-axis, and the vertical line x equal to 4. Now you can see from this function here that the denominator is always going to be positive for any value of x because of the square in this x, and the numerator has x to the first, so when x is positive, the graph will be above the x-axis because the y component is positive. When x is negative, it'll be below. So from that, we can get an idea of what the graph looks like. We don't have to know the exact graph, just basically where it's at. So just from that, we know that at 1, the value of y is 1/2, so it goes up. And then as we go to the right, the value of y decreases. So because the degree of the numerator is less than the degree of the denominator, this has a horizontal asymptote, which is the x-axis, y equals 0. So as we increase the value of x, the graph again approaches the x-axis. And on the left, as we go to the negative side, the graph approaches the x-axis also, but it stays below the x-axis. So the region that we're looking for here is this region right here, between the graph and then the line x equal to 4, bounded by the graph, the x-axis, and the vertical line x equal to 4. So right there's the graph. And that's just an integration problem. So it's going to be the integral from the origin to where the line x equal 4 crosses the x-axis. Of course, it's going to be at 4, 0. Well, let's just clear this. So we can just set it up. Say the area would be the definite integral from 0 to 4 of this function, x over x squared plus 1. Dx. So it's just a matter of computing the integral of this, which is, notice here the derivative of the denominator is 2x. We have an x in the numerator, so that suggests that the integral should be 1/2 natural log of absolute x squared plus 1. And since we have a definite integral here, we don't need the constant of integration. Now if you don't see this, we can just do it this way. If you want to see you can use a u substitution and let u equal to x squared plus 1. So du will equal to 2x. This is 2x and this will be dx. Derivative of constant of 0. So of course divided here by 2. So we can replace the dx or x dx, replace the x dx by du over 2. So here on the side we'll just say, okay, this is going to be, this will be the same thing as replacing the x dx by du. We have du. Replacing the x squared plus 1 by u, we have this. And then of course this is one of your standard formulas used a lot in calculus 2. Antiderivative, or the integral of this, is ln of absolute u. And then replacing the u by x squared plus 1, we get the same thing we got here. And of course here we have the 2 because of this. X dx is replaced by du over 2. I just put the 2 down here And then of course this will go here. And then over here we have limits of integration. So this will go from 0 to 4. This will be 1/2. Then we evaluate this thing at 4. We get the natural log of, it'll be 16. 1 to 17. And of course the absolute value of 17 is 17. So I can get rid of the absolute value. And this will be minus. And evaluate this thing at 0. Log of 0 plus 1 is 1. Log of 1 is 0 times 1/2 is still going to be 0. So all we have here is 1/2 natural log of 17. So if you do that on your calculator, the area comes out to 0.42. And that's square units. And that's your solution to that one. Now let's go ahead and clear this. But we don't have to clear it. Let me just bring up the calculator. Obviously the instructor would want you to do it this way, show your work. But you can use your calculator to double check it. Go to Math. And then scroll down to number 9 here. Hit enter. That's the definite integral. So we enter the function. This will be x divided by, in parentheses, x squared plus 1. So we want the definite integral of this one. So we go and enter comma and then tell the calculator the variable we're using here, it's x, and then another comma. And then the limits of integration are from 0 to 4. So enter 0, comma, and 4, close parentheses. And let's see if we get the same answer here. Of course, I just computed the natural log of 17 and divided that by 2. Hit enter. And we get 1.41. Run that out to 0.42. And I just left out the 1 there, 1.42. And let's confirm it here. If I take the 0.5, which is 1/2, the natural log of 17, I get the same thing. Okay, so just a little error, left out the 1. Instead of 0.42, it should be 1.42. There it is, 1.41, run that out to 2 places, 1.42 square units. Okay, thanks for watching, we'll see you next time.